Let's talk about a scenario. Imagine a company, we'll call them Automate Corporation, and they've just built a revolutionary new AI. It's poised to change everything for them, but it also opens up a massive new security risk. So the big question is, how do you protect it? Today we're going to dive into how to build a digital fortress around a powerful AI system and turn those potential vulnerabilities into solid strengths.
You've got to understand, an AI like this is a total game changer for a company like Automate Corporation. We're not just talking about a small upgrade. It's designed to completely revolutionize how they operate, making the whole company smarter, faster, and way more efficient than ever before.
And its power, well, it comes from having the keys to the kingdom. It can read internal company documents, it can dig into application databases and logs, and it can even classify highly sensitive data. And here's the crucial part. It interacts directly with both the internal staff at Automate Corporation and their external customers. So that brings up a really critical question, right? What happens if this incredibly powerful tool with all that access gets turned against us? The stakes? Well, they could not be higher. And that is exactly why having a rock-solid security strategy isn't just a nice-to-have, it's absolutely essential.
So here's our game plan, our defensive blueprint. We'll start with our core strategy, which is all about something called compensating controls. Then we'll talk about guarding the perimeter, securing the inner sanctum, and even planning for how to manage a siege. And finally, we'll pull it all together to see how we've built a real fortress for the future.
Any good fortress starts with a solid blueprint. In the world of AI security, that blueprint is built around a really important concept called compensating controls. So let's break down exactly what that means for Automate Corporation.
So, what in the world are they? Well, to put it simply, compensating controls are the extra safeguards you put in place after you've analyzed the system and found its weak spots. These aren't just the default security settings. Think of them as custom-built reinforcements designed to fix the specific vulnerabilities we've discovered in our AI.
And our whole approach follows this really clear three-step process. First, we hunt for a weakness. We analyze the AI from top to bottom. Second, once we find one, we apply a very specific, targeted control to fix it. And third, we use that fix to harden the entire system, making sure that kind of attack can never, ever happen again.
All right, so every fortress needs its outer walls and its gatekeepers, right? In AI security, this first layer of defense is what we call the perimeter. It is all about controlling what gets in and, just as importantly, what gets out.
First up, we've got prompt firewalls. I want you to imagine these like hyper-vigilant security guards at the main gate. They inspect and filter every single request, every prompt that gets sent to the AI. They're looking for malicious commands, things like ignore your previous instructions, and they sanitize the text to stop those attacks cold before they even get close to the AI's core.
Next up, we have model guardrails. Now, if the firewalls are the gatekeepers, think of the guardrails as the high, impenetrable walls of the fortress itself. These control what the AI is allowed to say. These rules enforce safe behavior, physically blocking it from ever leaking sensitive data from Automate Corporation or generating a toxic or harmful response.
Our third perimeter control is all about using prompt templates, and you can really see the difference here. On the left, you have this vague, unstructured request that is just wide open for manipulation. But look at the right. The request is forced into a secure, predictable, structured format. This makes the AI's job simple and clear, and it drastically reduces an attacker's ability to trick it. It's a game changer.
Okay, so we've secured the perimeter. Now it's time to go deeper inside the fortress. We need to secure the inner sanctum. This is where the crown jewels are, the core data, and the AI model itself.
And the guiding principle for everything we do in here is actually pretty simple, but it is incredibly powerful. We have to ensure that users cannot access any capabilities of the model that are beyond their specific role, period.
This table shows exactly how access controls and what we call the principle of least privilege work together for Automate Corporation. So, a customer, they can only see their own data. A support agent might be able to see customer data, but they definitely can't change the AI settings. A developer can tweak the AI, but they can't see private customer data. See? Everyone only gets the keys to the specific rooms they absolutely need to be in. No more, no less.
Next, we have to make sure the AI learns from authentic, trustworthy information. Data integrity controls act like digital fingerprints. We use techniques like hashing, which creates a unique signature for a file, to verify that none of the data has been tampered with.
This is so important because it prevents something called model poisoning, where an attacker tries to corrupt the training data. This guarantees our AI learns only from trusted sources.
And of course, there's encryption. This is our secret code. It turns sensitive data, like Automate Corporation's financial results, into complete, unreadable gibberish for anyone who isn't supposed to see it. This protects everything, from the AI model's weights to the logs of user prompts.
So, you've got strong walls, you've got secure vaults, but none of that matters if the gates just get totally overwhelmed. This final layer of defense is about managing a potential siege, controlling the operational flow to keep the system up and running even when it's under pressure.
This brings us to rate limiting. See, an attacker could try to crash the whole system by flooding it with millions of automated requests. Rate limiting completely prevents this. It just caps the number of requests allowed from any single source. The attack gets blocked, and the system stays stable and available for all the legitimate users at Automate Corporation.
Okay, let's pull it all together. After putting all these pieces in place, what does this layered defense really mean for the future of AI at Automate Corporation?
The key takeaway here is that there's no single silver bullet. There's no one magic fix. Real, true security comes from having these 8 distinct, interconnected layers of controls, all working together to create a powerful, resilient defense for our AI system.
So why does all this matter so much for Automate Corporation? Well, because a layered strategy like this dramatically reduces the impact of any attack, it prevents known threats from happening again, and it hardens the AI against attacks that we haven't even seen yet. It creates a true defense in-depth posture, which is really the gold standard in security.
So, the fortress we've built for Automate Corporation is strong. It's resilient for today. But the world of AI security is constantly, rapidly changing. As the attackers get smarter, the question we always have to be asking ourselves is this: what will the defenses of tomorrow need to look like?